Good morning. Okay, today is Tuesday, the 28th of August 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day, and I stream it here on Twitch Monday through Friday. Hello to Gunngine, and it's Coder's Life. Today we're going to do something a little different. Gunngine has asked me to look at his Gunngine code base, and I agreed to do that, and I'm just going to go through it. I know he has some questions about, is he using all the features he could be using? Is it designed well? And I think there's some concern over having a God object, which we'll look at. And also I think I had done a tutorial video for timers, and he had some questions about getting that integrated into the code base. So we'll take a look at that too. Yeah, so we will dive right in here. We won't rip it apart. But I'm going to run this real quick just so we can get an idea. You guys probably won't, I don't know if you'll hear the sound on this because I don't think I have it piped through. But there's some pretty cool music that's playing. And it's tricky. So this is the game, and so let's, I guess, start at the beginning, huh? Let's just start at main. So I assume we're casting these to tell the compiler don't generate a warning. Now we're creating a UniqueFooter around a Gunngine instance here, so we're getting one version of the engine object essentially, which looks like it's taking a title and the window size, and then we get that pointer back. We're calling init. If that returns true, then we're looping over doing our pretty much standard game loop, right? Is the game running? Process input, update, draw, and that's pretty much it. And then game reset, I'm guessing releases stuff. Oh, is this? Yeah, this must be on a UniqueFooter. I don't think I've ever. Yeah, you shouldn't have to call that explicitly, I guess is where I was going with it. Because the whole idea behind UniqueFooter and shared footer and things like that is that when they fall out of scope, right? So for all intents and purposes, when you hit this bracket, this scope dies, and this is an auto. So UniqueFooter is a struct class that's an auto on the stack. Internally, it has a pointer to the thing that you're allocating, the type here. And then when this auto gets destroyed, when it exits the scope here, then internally, right, this is RAII in C++, resource acquisition is initialization. When this auto gets destroyed, internally the destructor is called, and then we free the memory on the heap related to the thing that we allocated. So yeah, this probably isn't explicitly required. And here's the other thing too, and of course this is, shh, don't tell anybody. But, it used to be the case with old operating systems, or should I say older computers that really barely had operating systems, that when a process exited, if it didn't clean up after itself, bad things might happen. With modern operating systems, and this does include wind blows, when a process exits, the operating system reclaims everything associated to that process. So even if you didn't free memory here, even if you just leaked it, that's known as an external leak. So there are two types of memory leakage. There's internal leakage, it sounds bad, and there's external leakage. So internal leakage or internal fragmentation, or external fragmentation would be, so internal would be things that are related to the process as it's running. So if you're fragmenting memory, if your memory allocator is fragmenting memory for your process, then your process suffers. However, externally, it doesn't really matter because the operating system sees the big chunk of virtual memory it allocated to you, and it just sees that as a nice large block. And when the process ends, it gets that back. The external fragmentation would occur if your process was extremely greedy and requested pages from the operating system, but then never used them. Then in that case, you are kind of technically fragmenting externally. You're not doing it internally because you're never using them. You're hurting the overall system because you're taking pages you're not using, presumably through something like break or sbreak or whatever. And the same thing is true of leaks, right? You can have a leak internally where you're not freeing memory, and that is stomping on your process's space conceptually. Or you could leak intentionally, like in this scenario, where you don't really care if this pointer gets freed because freeing it is the same as the end of the process. I don't know why I went on that tangent, but it's interesting stuff to know. Okay, so let's take a look at Gunngine. So I'm gonna make edits because it's just the way I think. It doesn't really, it should get just the way I think. And one of the nice resharper for Visual C++, it shows you stuff that you're not using. C-Line does the same thing, it just does it differently. It doesn't shade them. Well, I guess it does, but it also will edit them out automatically. There is a product called ReSharper for Visual C++. So if you install that and it's enabled, then it will. You see these symbols here on the left. These are all from ReSharper. It's highlighting these inlines. This is from ReSharper. These little things that it's suggesting here, right? This is all ReSharper. Okay, so we got our pretty standard include headers. We've got some constants here. What is resharp versus probably spelling? Yeah, it's spelling, and it doesn't because these aren't pound defined. It's wanting them to be lowercase, but of course you can control your style however you want. So everything's private. Okay, so here's an interesting thing, right? Now, I don't quite know why. Well, I do, I guess. So the convention I always follow, just because I think the very first C++ code I ever saw, which was probably code that Bjarne wrote, private by convention in C++ always comes last. It's always at the bottom of the class declaration. And the reason for that is because C++ kind of follows the mantra, or the original mantra, I guess, that private is really the state part that should be uninteresting, right? It's not the API of your thing. It's the internal workings of your thing. Now this is where we get into philosophy and all nonsense, but I'm just, kind of explaining, I guess, why I've always put private stuff at the bottom, right? Because the idea is that your public interface is what people want to see, especially when you're looking at a header file. Because the idea is, if I'm looking at an encapsulated class, even though the declaration has all these fields and stuff in it because it has to, that's not how I'm going to interface with this thing. I'm going to interface with it through these methods. That's the first thing that I want to see. And then if it's an extendable thing, if it's a plug point in your implementation, then your protected would follow, because then the next thing that you would want to see is, if I wanted to inherit from this class and override something, what does that API look like? Now, if it's a struct, it's the opposite, right? And in C++, I mean, I would consider that kind of the semantic distinction. Well, and obviously there is the defaults are reversed, right? But I think of structs as data things typically, and then classes, I promote things to classes once I start actually encapsulating behavior and I have an actual public API for that class. And as a total aside, this, in my opinion, was one of the reasons why test-driven development kind of was a thing, right? Because in a way, if you think about, I'm going to encapsulate this thing, what does that look like? How do I use it, right? The best way to build a public API in a class is to actually write code that would consume it. And then very quickly, you can see, oh, yeah, okay, I need to do this, and I want to call that, and I want to be able to, frob the frizzknob and whatever. As where if you just design it all in your head, you never exercise it, then it can be, you'll be surprised perhaps later. Oh, I missed this, I need that. Now, it's my contention that eventually, if you do this long enough, you can get to the point where you can pretty much infer, again, because it's just repetition, it's just patterns, what the public interface is going to look like. But anyway, another aside. This is not, it's not a huge deal. This is a style thing, but I just mention it, I am not getting paid, no. Uh, you don't, well, again, if you want to be very explicit, you can be. You don't need to explicitly not to delete the default constructor. If it's not there, and this is the only constructor, then there is no default. So now I'm going to just kind of look at the data in this thing. So we've got the STL window, the renderer, the title, screen width and height, difficulty, health, converted lives. I'm curious why that's a const char star. And why, yeah, like why is that a string and that's not? I'm not sure. Okay, yeah, so in that case, you can do cstir on your strings. So then you can have, you can be standard and have string everywhere. Yeah, okay. So you're trying to avoid having to explicitly do the conversion. Gotcha. All right. We got the keyboard, the mouse, HUD. Okay, so let's look at the CPP file. That's interesting. It's right there. Okay. Yep, so we got a pretty standard constructor. We passed in the title and the width and the height, and then we initialize stuff. Doing some asserts. Not sure why ReSharper or Visual Studio, I think it's ReSharper, it's complaining about that. Not sure why it's not seeing it. Constructor calls cleanup. Yeah, I did that intentionally. I mean, it compiles. What's interesting is, okay, there it goes. It just took it a while to pick it up. All right. Update Delta. Yeah. Set up game objects. I love that comment. Rewrite the text class entirely. This is shit. That's great. Again, this is in C++, the convention is to use size t for iterators and things, for indexes. Counts and indexes and things of that nature should be size t. It doesn't, again, like a lot of this stuff is provisional depending on what you're doing. The other thing, and I know there's a huge amount of debate on this, so like that would be size T. Because mitem size should be, it's returning a size type, which is a size T. So yeah, then these types match. The other thing that, again, I know there's a lot of debate, but if we go back to the header file, like using the primitive C types unsigned to int, I avoid that like the plague. I use the C standard int type defs, so that would be the UN int 32, UN 32 T, because those are based on the type defines, and you have header files that are checking platforms and all that good stuff, and you're going to get exactly what those are. Versus, again, this is probably meant for Windows, and that's all it's ever meant for. It probably doesn't really matter. But if you move to different platforms, you may be surprised what some of those types are. I have no idea why it's flagging that, because it builds. This is why I don't use Windows. Yeah, okay. So, yeah, I mean, really, this is your setup stuff, right? Is where you're loading all your assets. I know you mentioned earlier, Gun Games, that you were thinking about creating an asset manager. I mean, you could. I mean, what you're doing here seems okay. I guess it depends on how much more complicated it's going to get, right? Init, you set up your SDL stuff, image, DTF, mixer, create your window, create your renderer. And then set your game running. Okay, Yeah, you got your SDL event loop here. Draw a level, you defer that down to your actual level object, drawing your paddles, you loop over those, draw them, draw your ball. So, all right, one observation I would make, and again, what is here is fine, right? So there's different ways you can look at this, right? If this code base is meant to make this game, then I would say what you have is fine. There's nothing wrong with this approach because the goal is the game, right? It's not some uber reusable, you're not trying to build perhaps a generic everything goes engine here for every possibility. You might do what game programmers have always done. You might rape it, you might cut and paste it over and then start changing it for the next game. But if your goal is to build the game that you have and continue building it, I don't necessarily see anything wrong with this. But with that said, I could see, again, I don't know how much more complex the game is, like from where it's at to finished, I don't know what that looks like. But I'm gonna speculate, okay? So the thing that I would throw out there, if you look at other larger games, and I'm going to stop short of saying AAA because it's not just AAA that does this, although you would definitely see this in AAA. What you could do, and again, there are risks to this, is you could genericize what you've got here as just an entity system, right? So, and this is where OO, yes, this is a game engine for a specific game that Gunngine is creating. So where was I at? So you can create an entity system, right? And this is where OO kind of potentially traps you a little bit in thinking. Like you have a ball, you have a paddle, you have text, and and you have items, right? Depending on how much flexibility you might need, one thing you could consider is what a lot of these other engines do, and like Unity does. I mean, Unity's based on this from the very beginning, is you have an entity system. Well, what's an entity system? Well, an entity system is exactly that. It's just a big collection, big array of entities, and there's only one type, essentially, in the model entity. Now, depending on, how fancy you want to get, you can tag that type with other things that it could point to that make it custom. But your renderer, instead of it dealing with separate things, then becomes just, here's this huge contiguous array of entities, and you pick some upper bound, right, for whatever you think your game needs, 1,024 or whatever. And instead of drawing level, drawing paddles, drawing ball, you just draw, right? And it's all entities, and it's just data that describes what it is. And by unifying, and I would include things like text and other stuff in that too, right? So by cursors, all this stuff that you have basically would become entities, and then it's less code driven, less type driven at that level, and it's more just data driven. What's the advantage to that? The advantage to that is now you have one generic model that you can optimize. Again, you can like pre-allocate an array that would handle the maximum number of entities you could ever want in your game. An entity can be anything that's on the screen, right? It could be, and not even just things that are drawn, it could be sounds too, right? So your whole model becomes this one abstract type that defines everything. So then you could build editors for that because it's just this one data type essentially. So then it's very easy to build layout tools and editing tools for your levels. Your code kind of simplifies because, again, you have an entity. An entity has bounding box. It has a hit. A hotspot. It has a position. It has a vector. It has all these other things that you can apply to it. And so then you only really have to plumb that once. And then you can have specialized handlers for different types of entity. So you can have unique behavior for them, unique rendering. Like if you wanted to do special kinds of, particle effects for a particular entity, that would be an example where you would customize, not necessarily through inheritance or polymorphism, but you would customize that entity in that way. So again, if depending on how much more complex this was going to get, that would be an example of how you could consolidate a lot of this design into one thing that is very data driven. And if it were me, and again, this is not what I'm saying is right and what you have is wrong, they're just different. If it were me, what I would probably do is I would probably have an entity system, and I would probably use a YAML file or some input file, whatever you like, so you don't have to build an editor right away, but you can define all of your levels, and all the entities and what their configuration is, essentially all in a config, and then build the engine to be able to consume that and do what it's doing now as a starting point. Then it would be very trivial. I say trivial, it's approachable, right? To then be able to build an in-game editor that essentially works off that data model, right? And then you can start building levels and customizing them and all that good stuff. So I know you mentioned gun games that you're kind of worried about this God object. And honestly, again, here's the thing. So there's this law in object-oriented programming. It's called Demeter's law. And interestingly enough, so Demeter's law is correct. And what's fascinating about it is that if you follow this principle, which is really the entire point behind OO, then having God objects is required. That's going to sound weird, but it's true, because if you follow the law of Demeter, you can't do what we would typically do, right? In these systems, you can't probe fields, you can't have getters and setters, you can't, and you have to have one object that is wholly responsible for the things under it. And then of course, when you go down that road, you discover then you have to have other whole, God objects. So I guess you start with God, then you have angels, you have, whatever. So, I mean, in the strictest sense of pure OO design, there's nothing wrong with, I mean, this object is responsible for all the things within it. I mean, that is a correct modeling. Now, here's where things get murky, right? And this is why I think OO is so overwrought nowadays. You hear all this stuff about don't have God objects, don't have manager objects, don't do this. And what a lot of that is coming from is this concept of decoupling. And why are they wanting you to decouple? They're wanting you to decouple because they want you to be able to test it. And yes, it's true that if you follow like the law of Demeter, then it can be difficult, right, to break units down, because by definition, if you have an object that is responsible for all these children, then technically those children don't stand on their own 2 feet, right? They in some way require that parent thing. But that makes testing difficult, because now you have this coupling. Well, this is the cat and mouse, this is the catch-22 of OO. Which do you want? Do you want a proper, well-factored law of Demeter, abiding OO system, or do you want something that's decoupled to the nth degree so that you can arbitrarily, mock and replace any part of the system at any point in time, and everything's injected and everything's passed around, so that nothing owns anything, right, in that model, essentially. But that's a trade-off. I would not argue that that's necessarily good design, per se. That's a design that allows for a certain kind of outcome to happen, meaning building something decoupled and, all wonderfully injected and all this great stuff, right? But again, from the context of what you're doing, you're just building a game. The idea that you have this one object that has all these other things in it, I mean, there's nothing inherently wrong with that premise. Now, maybe, but again, I'm just like shooting from the hip on a lot of this, but maybe like lives and health and things should not be in the game, maybe, and like difficulty, I don't know, maybe that should live in some kind of player stand-in. But again, that's, now we're stuck in the philosophy of OO again. Now we're creating things because in the real world, that's the way you would think of it, but does it have to be implemented that way? No, not necessarily. So I'm going to look at some other stuff here. So One thing I would say, I noticed that you're passing by reference when you have a pointer. I would say you're paying a price to do that because you have to dereference the pointer to pass by reference. I would just pass the pointer. Again, there's nothing, I think I've posted this before, but there, like Herb Sutter's given some good talks about the fact that just because we have, things like UniqueFooter and shared-footer in C++ doesn't mean you don't pass raw pointers around. In fact, you're supposed to. That's part of the convention. Because those things, those types, those are ownership types. Those are life cycle types. Ideally, you can't pass, really, a UniqueFooter around conveniently. You can pass a shared-footer around, and there are reasons why you would do that. But if all you need is a non-ownership pointer to something, just pass the pointer. So I would pass pointers. If it started life as a pointer, I would just pass the pointer around because you're paying a price to convert that. Now maybe the compiler's super intelligent and is noticing that you're taking a pointer and dereferencing it and turning it into a reference, which is then under the covers just a pointer. But yeah, I wouldn't trust that, right? Plus, it's just more consistent, right? You're passing that pointer everywhere around, and again, this is it's not wrong. It's just I would probably just pass the pointer around. So here's an example of where, again, this kind of depends on what you're doing, but you're making a copy here. Maybe you want to, maybe you don't. You could return a const reference on this, and that would be, in this scenario, that would be faster. If you wanted a read-only representation of that, because you could always copy it right on the receiving at the call site. You don't have to enforce the copying here. Now, with that said, the C++ compilers today will optimize some of these scenarios, but again, this is something you might want to think about. If you're returning a struct, and it's a struct that's inside of your type, and you can safely take a reference of that, I would consider it, but it's small, right? It's not a big deal. Another thing, again, this is just style. Some people like very explicit code. I do too, but I typically create type defs. If I'm going to have lots of repetitive UniqueFooter, shared-footer, shared-footer, vector, map, whatever, I'll create type defs for them and give them a better name. Plus, you don't have to type the less than and greater than as much. But again, that's just a style thing. It's not like that is the way to do it. Oh yeah, I just thought of something. So in the gun engine, so you have a lot of bools, running pause, game over. One suggestion I would make here, Visual C++ definitely will not do this correctly. Maybe GCC and Clang will compress this. I would turn this into flags or an enum or something instead of having a bunch of bools. Boolean types in C++, C are wasteful in general. So yeah, I would collapse that down into something. You have some things here where I mentioned like flags because it looks like you might be able to have a couple of these on at the same time. So whether it's just a flat enum class or whether you have flags that are combined to represent the current game state, I would just collapse that down, and then I would add some helper functions to be able to get and set state cleanly. Again, I hate to even talk about style stuff because it's, especially if you're just doing your own thing, but there's a couple things I'm noticing. Naming consistency, right? If you're going to use camel case, use camel case. If you're going to use Pascal case, use Pascal case. Don't alternate between them. Also, again, this is not right, wrong, one way or the other. It's just, I would avoid all caps, with stuff. Because especially in C and C++, then it can be sometimes confusing. Is that a pound define? Is that, what is that? So I try to avoid all caps on things. The other thing that I would suggest, but again, this is just style, but any shop I've ever worked in, going all the way back into the 80s, things like this, right, would typically get dinged in a code review where, here's 80 columns right there. So like this is kind of your cutoff point. Hey, Dr. Robot, you're doing pretty good. Hey, Murtis Wee. Hey, the tall pants. Yeah, this is parallels. So yeah, a lot of programmers don't have a hard time, or they don't. It doesn't bother them that things go very horizontal. I guess I got 80 columns beat into me in a different era, and so it always feels weird. But so this is a little confusing. Yeah, I would not expect that on a keyboard. this is being copied, which again may or may not be a problem. Yeah, again, I don't know if there's some difference between some of these, like why these are Pascal case and these are camel case, but I would just pick one and be consistent with it. Yeah, so like mouse and keyboard, I guess those are sort of stand-ins for the player. I mean, it seems that way. So yeah, I would say mouse and keyboard might more naturally be player, and that stuff just gets consolidated down. And player has paddles. Conceptually. How that actually gets implemented. Yeah. Yeah. Again, like, so this is just, it's awkward, right? You have a pointer which you're dereferencing, so you can pass a reference, so you can get an address, so you can compare it to null. I would just pass the pointer through. When you need nullness, right? There's nothing, again, at least from my perspective as a C and C++ programmer, there's nothing wrong with nullness. There's nothing wrong with pointers. They're fine. Right, if you need null, then references aren't the right thing. Not sure what screen state manager is all commented out, so I'm gonna skip over that. Sound looks like it's just a wrapper around SDL mixer. Text, yeah, fonts are always fun. Yeah, pretty straightforward. And then timer, I think, was what you got for my stuff. So really, I mean, overall, my impression of this is that for a game, if your goal is just to build this game, I don't see that you're on the wrong path. Of course, there's, small little things here and there that you could change. But again, a lot of them are just nothing I've mentioned, I think, is going to make or break your game, right? Like, it's so I'm trying to think, again, I would say the largest issue I have, just from a type perspective, is keyboard and mouse. That's just a little confusing. I mean, I get it because this is doing the keyboard thing and the mouse is doing the mouse thing. But I don't know, I would just consolidate that into a player because that's kind of what it is. I don't know if I looked at this. Oh, yeah, pretty good. Yeah. One suggestion, most of your constructors just do asserting, which is fine. And you can do small things in constructors. I really try, just personally, I try to avoid putting any real serious behavior in a constructor if I can avoid it. Because, quite frankly, constructors in C++ are just weird. There are just certain things you can't, virtual method calls don't work right. The object's kind of mostly alive, but not quite. There are some subtle differences between compilers. So in general, like this sort of thing, I would want to move to like an init or something on a type. Yeah, it's sort of a pain, but you have to do that. But again, it's not a make or break thing. If you find, if it works, what you're doing, then. But here's the, like here, you're loading textures from the file system. So this is inside of a constructor, like when this blows, it's just not as easy to work with, in my opinion. But again, it's a small thing. I mean, this is very minor, but right, you can hoist that because the level number matches the index, and actually so does that, right? So you can collapse that down a little. I don't know. I mean, maybe level num isn't always contiguous or aligned with that, but I'm guessing M level textures is an array. Yeah. So, yeah. Yeah, really. I mean, it's not bad. So, then for the timer stuff, Yeah, okay, so following your pattern here, I would just include the timer here, and make your timer pool. Of course, I got that bundled up with your sound. I'll put this down here. And then, oh, okay. So there's, how did I do this? I can't even remember. Nibbles, question answer. Right, okay, yeah. So it was, so if we go to, so we create the timer pool, and then an update. I would just call timer pool update. And if I remember correctly, yeah, that's correct. So in your top level, I think that's it, really, to wire in the plumbing on the timing. So all I had to do was, so I added the timer pool to the game engine, which I did down here. And then in set up game objects, I do a make unique for the timer pool. And that gives us our instance of that. And then two things in process input. So this is if you want to use the SDL thread-based mechanism. The way that works in the timer pool is because the SDL thread-based timers, it's on a different thread, it's not on the main thread, and you can't do any UI stuff off the main thread. So it shuttles the event back to the main UI thread via the SDL event queue. So then what we have to do in here is we have to be listening, right, for a user event. And if we get it, then we know we can cast that field to the timer T struct pointer, and then from there we can call the callback, excuse me, on that. And we pass in the timer pool pointer, raw pointer, and the timer T struct pointer. And then all that works normally. And then in update for the game, we just call update on the timer pool. And then from there, you just create timers wherever you need to. Now, here's the trick, is since the gun engine owns the timer pool, you might have to expose a getter, right, so that you can get a pointer to the timer pool. Depends, right? It depends what part of the game is going to be creating the timers and stuff. So maybe you would pass the pointer to the timer pool down, so that whatever part of the game needs to create timers can do that. Yeah. So that was pretty much it to change that, to enable that. And let's just make sure it doesn't crash. Looks pretty good. Ah, I died. I suck. Ah, I'm just not very coordinated. Oh no. No, where is it? This music reminds, you guys probably can't hear it. This music reminds me of Paul Norman, music he used to create. Ugh. Yeah, I suck. Anyway, yeah, I think it's... So, I don't know, Gun Games, if you're still around or not. But, yeah, overall, I mean, again, it ultimately depends on how much more complex it's going to get and, you know, where you're going to take it. I plumbed in the timer stuff. So, I mean, at this point, you would have the timer pool and you'd be able to create timers with it and, you know, use those. I'll zip this up so you can just grab this and compare it to what you have. again, if I were to say, is there one big change? And I'm not necessarily saying that this is right or wrong. I'm just, if it were me, this is the first place my brain would go. Is probably like doing a generic entity system. Is probably what I would consider, right? But I would only be thinking about that if I had to do lots and lots of custom level stuff, right? Like if I knew that, most of the game, like the mechanics of the game are going to be pretty simple, but I needed to spend a lot of time building like 100 levels or something, or 100 scenarios that you played under. I would want to make that process as seamless and as easy as possible, because that's going to take a lot of time. And if you find a problem, in one level or whatever, you probably want to be able to quickly go change some data real quick, and boom, there you go. It's fixed. Also, if you plan on localizing the game, having it being data-driven, all that data-driven is going to make localizing it easier, potentially. But that would really be, again, it all depends on what the end goal is and how much more complex it's going to be. Lord Bourne says, wow, is this a gaming channel now? It's always been a gaming channel. It's just I go on detours. Zane says, what do you think of Kant's correctness? As nice as it is, I always hate reading and writing something like const t star const. Yeah, I mean, a lot of this stuff, right, like Kant's correctness. I'm going to get in big trouble. At the level of the CPU, and I'm going to elide things like privileged access and execution flags and memory regions and all this stuff. Yeah, okay, so you can do some of those things. Yeah, here you go. You can do some of those things at the CPU level, but fundamentally, right, like the CPU doesn't give a shit. Memory's memory. You can read to it, you can write to it. So these things that we put on top of that, like Kant's correctness, what are they for? Well, they're the idea, again, if you're building APIs, if you're building interfaces to things, the idea behind Kant's correctness is if you don't want something to be mutable, then you're doing a couple things. One, you're telling the compiler, hey, help me out here. Don't let people change this thing. But you're also theoretically conveying your intention, right? You're the person who's consuming your API can see, hey, they intended for this to be read-only, right? But just like you say, anybody could get around that if they wanted to. So it largely is, these kinds of mechanisms are, I look at these as team mechanisms, like multiple developers working on a code base or a consumer consuming some third-party thing. And, that's really what you're trying to, now there are benefits to constness, right? Because the compiler can infer certain kinds of things because something is theoretically read-only. But yeah, I mean, at the end of the day, if it's just you and nobody else is ever going to look at your code, do you need to protect yourself against yourself? I don't know, that's kind of one of those things, right? It's just, you have to, do I really care? That's the question you have to ask. Now, if you're working with other people or you're building something that's going to be consumed by other people and you want to, that's one of the other ones, Postal's law, right? You want to the robustness principle or Postal's law, right? Be conservative in what you do, be liberal in what you accept from others. So just don't surprise people, right? So if you're building some kind of API and, constantness could theoretically go some way towards ensuring that people don't accidentally consume your API in a way that wasn't intended. With all that said, right, there's tons of C code out there that doesn't have that. So, and it works just fine. And there's large teams that work on C code bases and they work just fine. So yeah, and see, this is where, like, you're writing an API, you don't really modify it, but you lock it. And this is where we, things that are, behavior becomes this confusing, muddled thing because it depends on your semantic context, right? And what does locking really mean, and I think the answer to that is if you give the user something, whether it be const or not, you ask the question, okay, if it's mutable, can they do bad things with it that you don't intend or that you can't recover from? And maybe that's a deciding factor. But then ultimately, yeah, exactly. It's semantics. It all comes down to, in the context of what you're building and offering, what does it really mean? Maybe locking is mutable, maybe it's not. And, you do what's right in that particular situation. The same thing, with this code that I was reviewing. I mean, like I say, there's really nothing wrong with it. Again, we go back to law Demeter, right? The idea that you have this game engine, that's owns all these things. I mean, that's not necessarily wrong. I do remember, so Gunngine asked me about like state machines and should he have a state machine. And I would say there's an ad hoc state machine here right now that's in, the engine object, the God object. Again, does it make sense to break out a state machine as a separate thing? It depends on how much more complicated the game's going to be, right? Is really what it comes down to. If the game is going to have a much wider variety of behavior than what we've seen so far, then I would say, yeah, you probably might want to break out a more complex or more distinct state machine. I did sort of address part of that with the bools here, right? These should be collapsed into either a straight enumeration value or flags, depending on how complex the state is in the engine. And then, at least the way I would probably do it is if you did introduce a complex I say complex, a separate state engine, right? A lot of what's in the gun engine now would really just be deferring to a state to say, okay, what should I be doing? And then that way you can define alternate behavior. Slaves, that's great. Have they gotten you coffee yet? Did they succeed in the coffee delivery task? Ah, bummer. Bummer. So, anyway, yeah, I mean, so I see Gun Games in chat, but I don't know if he's still around. He might have, I know he kind of works third shift. Yeah, it looks like he's offline in Discord. So I'm sure he'll see the VOD. But yeah, I mean, what I would say is I'll make the changes I made. I'll zip these up and make it available to your gun game. We can chat later, but yeah, I mean, overall, I don't really see a whole lot that I disagree with. I think it's fine for what it is. And I would go one step further and say, you know, if you had ideas of like this being a general engine for any game, again, I would take the 1980s and 1990s game programmer approach to that one. I would say, okay, fine, you know, finish this game. Then when you want to start the next game, copy the code, literally, and then start changing it, right? And I don't think there's anything wrong with that approach either. Like the notion that you have to reuse everything purely as libraries or whatever, that doesn't always work. Sometimes it's easier to treat something as like a skeleton or, you know, a template, and then go in and start changing it. And if you look at a lot of games in the past, that's exactly what they were, right? They were not, oh, this is some Uber shared library that, you know, or shared code base that everybody links in and they just write these little, you know, customization points. No, you know, people would take a previous game and it was similar or, you know, close enough, and they would literally just copy everything and start changing it. And then if you looked at the code, right, you would see comments from other games and other, you know, because that's where it came from. So anyway, that was fun. You guys got to see me use wind blows. I guess I've done it one other time on stream. I've used wind blows. Wind blows. Here, let me zip this up before I forget. Because if I don't do it now, I'm going to forget. Zippy, zippy, zippy. RAR, I should say RAR. So earlier I was talking about unit testing and how decoupling becomes somewhat of a requirement because it's not sufficient to test one object from the top down. No, you have to test every single object in isolation. And and what I was going to say is I saw yesterday, I think, on Twitter that Uncle Bob, he posted or tweeted, whatever verb you want to use, that he used the analogy of accountants, right? So accountants use the practice of double entry bookkeeping, which changes the structure of the system. And then developers that are using QDD changes the structure of the system. And I thought that was kind of interesting. And I'm still not really sure what I think of that. It's still uploading. Hey, Slayer Darth. Yeah, I've answered questions or done projects because people request them. Yeah. So if anybody else wants me to butcher their code on stream, let me know. Oh, man. I am going to take a short break. I'll be right back. Don't go away. Okay. Slayer Darth says, WordPress plugin reviews? I suppose. Why not? Zane, oh, I'm so ready to get butchered. Though it's a whip. Hey, do you have a URL I can look at? If it's on GitHub or Bitbucket or something, I'll take a look. Yeah, my mbuff thing isn't good enough for review yet. Yeah, I was, I know I've mentioned before the idea of kind of how I do my daily routine, my daily development, where I try to put in a certain amount of time. And somebody asked me recently about that. I was talking to them, and I used the writer analogy again. They're like, well, what writer, you know? So I was searching, and I found, you know, Stephen King talking with, what's his name? Martin. You know, the guy who likes to write about food. J.R.R. Martin. Is that his name? Anyway, obviously, you know, he's a very slow writer. It's taken him a long time to get through his books. And King is very prolific. And so he asked King, you know, how do you write books so damn fast? You know? And King said, I try to get 6 pages a day. So King's metric is a little bit different. It's not time, it's a number of pages. And typically with authors, that's the case. Now some of them work on time boundaries, but in general, you know, from what I've seen, a lot of authors are page driven, and but I like the way you phrased it. I try to get at least 6 pages a day, and that's really, you know, that's probably a lot, really. I think that's a lot, and he even goes so far as to say that they're polished pages. So he's really putting some effort in there on that. But I mean, he does the math, right? Like if he writes a manuscript that's 360 pages, and he does 6 pages a day on average, he's done in 2 months, more or less. And he's Stephen King, so he probably doesn't have to be edited as much as other people have to be, which really means he can tell editors to go jump in a lake if he doesn't like what they're saying, versus less popular authors where they probably have to play ball more. But again, the mentality of you pick some target that you think is reasonable, and you just try to do that every day. And I saw something on Reddit, I think, this was a long time ago, and it was very similar, and I think that the gist of it was somebody was asking how, you know, they had no motivation, they couldn't get anything done, and this person wrote this really long reply, and it was, just get one thing done. Every day, get one thing done. And, that tends to have a snowball effect. And it gets you past some of those hurdles, I guess, of not starting, not. Magnum baguette. I always wonder what a magnum baguette would be like. I sometimes feel like you're my dad. That is what brings me here every day. Wow, I feel old now. But thank you. That was a wonderfully nice sentiment. One day at a time. That's right. Inch by inch, life is a cinch. Yard by yard, life is hard. I think it's a pretty old saying, actually. Yep. Yeah, if you have to do it, you have to do it. I mean, that's the thing, right? It's like, you have to look at the whole, but you shouldn't focus on it, right? It's like, I don't really pay much attention to the fact that I have, 46 things to do. Yeah, sure. If you want me to look at one, I'll look at one. Why not? I'm assuming it's written in PHP. I am not a code bigot. Come on. I recently wrote some COBOL, so, how can I pass up looking at PHP? I wanted a nick that said Dad, but apparently that makes me look edgy. That's pretty good. Now I understand. Sure, shoot. OS X's font rendering is so much nicer. Oh man. Actually, now that you put both of those there, I'm not really quite sure. They might be very close together, in fact. Probably the former, I would say, if ever so slightly. It's strange because, like, when I write COBOL, it brings back memories of when I worked at IBM, mostly, which were very positive memories, but they're older memories. And then I get kind of all nostalgic, and things were so much better back then. So Magnum Baguette says I remind him of his dad, which I hope is a good thing. And I had somebody say that they reminded me of college professors. I think specifically what they said was, you sound like a college professor. professor or university professor. I have no idea what I was saying at the time. Probably nothing good, but bless. Liberal arts professor. Oh God. So there was a thread on Hacker News yesterday that was quite popular, and it was about, well, really it was largely about TripleByte, because the blog post was essentially marketing content for them. The topic of the blog entry was them writing response emails to candidates. And I read that thread with great interest, and then finally I responded to the guy who wrote. He had posted something in one of the many threads there, and I responded to him because he had said that he was responding to somebody else who had previously done TripleByte interview and had gotten a rejection from TripleByte, and the guy from TripleByte, I'm going to paraphrase here, essentially said, you know, read Cracking the Coding interview and go to LeetCoder and do timed trials, because, you know, what employers are really looking for is for you to be able to write highly functional, quality code quickly and on the fly. And that particular, and again, I'm paraphrasing, you know my memory, but I think that's roughly right. And I just couldn't take that one. I had to respond. And I basically asked, I said, you know, can you tell me what it is about this that employers find appealing? What is it about speed in our profession that in any way makes a difference, right? I mean, if you think about that, I mean, software development, everybody says software development is not about typing. It's not about writing the algorithm in the moment. It's about thinking about the overall design and how those pieces fit together. And I mean, okay, sometimes things just click, and you can find an answer rapidly. But other times, you know, you really have to think about stuff. You have to let it percolate, right? And I mean, I don't get it. And then, on top of that, I mentioned that, you know, I would say basically every agile methodology out there right now is kind of implicitly, and a couple of them are explicitly, against that sort of machismo programming attitude, right? That I'm just gonna go blow everything away and be a cowboy and solve these problems at breakneck speed because everybody else is an idiot, sort of an attitude. And I mean, like, you know, most of these companies are probably doing Scrum or Kanban or some mix of that, and of course they probably have Jira in there too, because they want to torture people. But it doesn't make any sense, right? Other than it's a proxy for we want kids. Right? We want, why do games? Why do time challenges? Well, because, you know, the youngins, that's what they're used to, right? That's what they're doing. That's cool. And they kind of buy, I guess, the cachet. They think that doing that brings them, as where I would just sit there and groan and be like, what the fuck? Anyway, that's still in my head. It sticks in my craw because I'm old and I'm a fart. Magnum Baguette says, hey, what are your thoughts about Rust? I feel like it's a mix of C and Python. First, I will say that I was pretty down on Rust actually at the beginning of the year. And then several people kind of baited me into doing some projects with it. And I did that, and I was more frustrated for a short period of time. And then I took a step back, and like I said, I let my brain do some stuff. It took a while, can't just go into in a room and solve all the problems in 30 seconds on a whiteboard. But, eventually, I think my brain kind of crunched my experience the first time around and said, okay, here's the mistakes you were making. And then I started working on another project, which I need to get back to. So overall, my impression of Rust has improved. I still think there are some rather unfortunate design flaws in Rust, which I will give these guys credit. They're working on it right now. I don't know how quickly they're going to have a great solution to it. And I do think that there's a lot of, I'm trying to pick a really good word here. Rhetoric is not probably the best, but it's close. There is a lot of evangelization, there you go, around some of the aspects of Rust that I think are slightly oversold. And again, that's probably because of where it's at in its life cycle, and eventually that stuff will kind of iron itself out. I think if the team that is maintaining Rust doesn't completely fall apart, and there has been some issue there as of late, and if they work on it for, say, another 5 years, and they address most of these ergonomic issues in the language, and hopefully some of the evangelization becomes more down to earth, not, every single line of code you write in Rust shall be safe because Rust. Then I think it could have a shot at a niche long term in the ecosystem, I should say. But those are a lot of ifs, right? So I don't know. And the way, programming languages seem to come and go, it really wouldn't surprise me too much if, there was a thing on Hacker News today, right? What was it? Is Rails still relevant in 2018? So this is what happens in our field, right? Like, Ruby's not dead, Rails is not dead, but it's dead, right? It's lost its spark. And for whatever reason, right now, Rust has a spark. And hopefully, right, that continues. But realistically, what will probably happen is that spark will die out. And in 10 years or 5 years or something, we'll see something on Hacker News, is Rust still something I should bother learning? Because something else will have come along, right? Some new fad that will promise the world and supposedly be the silver bullet. In terms of the language, mix of C and Python, I guess, sorta. To me, Rust has little bits of C in it, it has little bits of Python in it, it has little bits of Haskell in it, it has little bits of lots of little, other things in it, right? It's not, I wouldn't say it's a really strong hybrid of any one particular language. They seem to have borrowed rather liberally from several. And in fact, if I remember correctly, Rust started life, was it Haskell or OCaml? I can't remember. But like the original, very early versions of Rust, right, were essentially DSLs in, I think either it was Haskell or OCaml, I can't remember, but one of those. But overall, I think, Rust has some potential, and I like writing tools in Rust, actually. Like I've kind of gotten some good leverage writing command line tools and some other things in Rust. Yeah, it's not a bad language. I think it has possibilities. Where Rust is weak, which sounds horrible, Rust is great if you write really small projects with it. Where Rust starts to break down is when you write really big, complex systems. Then the cognitive burden on the developer becomes quite great, in my opinion. Even once you get the ownership mentality, kind of firmly rooted in your brain, it still is, it's a heavy weight to have to carry around. Right, exactly. It's kind of ironic, right? Is that once you start doing the thing that Rust supposedly should be really good at, you start to suffer because of it. So at least that's just been my experience with it. Right, exactly. And I think, again, they're working on a lot of these issues. Like I saw something recently where they're working on a brand new borrow checker that's going to be much more flexible, it sounds like, in terms of allowing you to, like, for example, borrow a mutable and an unmutable reference in the same scope when it's safe to do so, because you already have a mutable reference anyway. But yeah, they're just, I think it's going to take time, right? So we'll see. Yeah. I also, somebody mentioned, oh, hey, go look at Elm. So I looked at Elm again, because I know I looked at it once before. And, yeah. And there seems to be a lot of politics there. And I see people bailing on it now quite publicly. And I guess the BDFL is extremely strict. And, yeah. Plus, Elm seems like it's very much geared towards web development, which is fine, but I don't know. Again, it feels like a procedural, frameworky patch on top of this underlying fundamental flaw in that you're building on these platforms that were never intended for application development. I mean, everybody keeps trying to approach like UI updating from this, mutable, immutable, top-down, I don't know, state delta thing. And I mean, my gosh, we've had Meteor, React, Angular twice, Elm. I don't know, isn't there something else in there too? Oh, Vue, which I've looked at Vue recently too, and yeah, I don't know, I don't see it, but As a student, the safety part of Rust made me want to look into it. I want to know what it does. Something is safe and implemented. Yeah. Here's the thing. Again, this is when I said rhetoric and evangelization of Rust. This is kind of what I'm talking about, right? Like, look, I don't consider myself particularly smart. I've built maybe now 6 smallish Rust applications. Maybe I'm missing something, but as near as I can see, at some point, Rust breaks, right? This everything is safe because of the borrow checker is true in extremely small contexts. But as soon as you have something that has some appreciable mutable state that has to be shared, and this is the problem. This is the problem, right? Like, this is what functional languages are supposed to solve. This is a problem of computer science, I guess, depending on which angle you're coming at it. But at some point, what happens is you end up using ref cells and ref counts, and what happens is the borrow checking moves to runtime, right? Well, once borrow checking moves to runtime, how is it any different than C#, than anything else, right? Now you're going to have code that compiles, but you don't really know if it's safe until it runs. And I mean, you can go through lots of contortions to try to avoid ever getting to that point, but eventually you will probably end up having to do that. And it goes without saying that, like, Rust gets a lot of its behavior today from C libraries, and there are Rust shims, right, that wrap that, but that's all unsafe code. So, and again, so once you introduce unsafeness explicitly, well, okay, maybe that's theoretically contained, but yeah, how good is that containment? I mean, there's, like I say, I think this safety thing has been heavily evangelized because it appeals to people. I think it's been overstated on some level. Now, again, I will say, I think the maintenance team, the core team for Rust, I think they recognize that they need to improve a lot of this stuff. And that maybe some stuff's been a little oversold, but yeah, time to tell, right, in terms of what they end up doing. Oh yeah, and I saw something on the web the other day. Now everybody's saying that Python is dead, and that Julia is going to be the replacement for that. Never believe the hype, right? If you're a student and you haven't read Mythical Man Month by Fred Brooks, you should read it. Yeah, it's an old book, but what's in that book is still true. Absolutely 100% still true. And our industry just loves to run on magic, right? They love to pitch stuff, hype it up. Look at Elon Musk. We're going to Mars. Never. Not in our lifetimes. So just, don't believe the carnival barkers, right? You have to dig, you have to really look. And it's not that there aren't good things that can be found there are. But again, like I say, our industry is very much run on hype. And I mean, just look at all the damn JavaScript frameworks. And how many times can we do that? But it just seems like it's endless, right? And as sure as I'm sitting here, Facebook will completely rewrite React at least 3 more times because they have thousands of programmers that aren't doing anything, so why not? I'm sure Angular will get rewritten at least twice from some point in the near future, just because. And it'll keep everybody chasing it, Then do you recommend I go with C++ over Rust for learning? Everybody knows what my recommendation is. Here's my mental model. My mental model is there is no magic in the world. Computers are machines, just like cars, just like printers, just like anything, right? A CPU is a finite device. It does a fixed number of things, and that is reality. That is what you have, right? You don't have anything else. You have the CPU and you have the devices that are on the bus that are connected to it. And therein also is physical reality, because we can only push electrons so fast, and there are space limitations, distance limitations, and the bus has an intrinsic performance lane, if you will, that it operates in. You need to understand what that is. Memory and peripherals work in certain ways, have certain constraints, and that's where you should start, right? You should understand the machine that you're working on. And once you understand the machine, then you can start layering abstractions on top of it. You can start to move a bit above registers and addresses and instructions. But once you have that fundamental understanding, in my opinion, right, it changes the way you approach problems, way that you approach programming. I wouldn't start, right, with C++. No. I wouldn't start with C necessarily. Again, I always tell people, if you are learning, you should start with assembly. Now that doesn't mean, again, I'll repeat this, that I think you should then use assembly language for everything forevermore. No, it's an exploratory process so that you can understand how these computers work, how these machines work, what is and isn't real, what is and isn't possible. And then once you have that, once you've built some software at that level, then go to C, right? Because C is essentially what I'll call really advanced macro assembler, more or less. And once you then have successfully done the same projects that you've done in assembly language in C, then you can move into something like C++. Because then at that point, what C++ is, the computational model of C++ is not really, again, if we set aside like templates, is not really any different than C. what C++ has is C++ has higher level constructs around type systems that allow you to abstract yourself even further, right? To some extent. But if you start there, right, it's a sea of noise. Like, where do you go? Where's the beginning? Where's the end? And I argue the end is Lisp, the beginning is assembly language, right? Don't start with, I mean, you can start with Lisp, but it's just going to seem like magic, right? It's just going to seem like, how does this work, right? It's not where you really want to start. And the guys who invented it, the guy who invented it didn't start there, right? He started with a CPU, and that's the key, right? You have to start with the real thing first. Then maybe you can find some good abstractions that fit on top of it. 8085 is fine. That's where I started. That was actually my first CPU. It's a great little CPU. Again, it doesn't look. If you take an 8085, which is essentially a Z80 with extra I/O instructions, and you compare that to a modern CPU. Okay, a modern CPU has a shit ton of extra features on it, right? Like, they have vectorization and they have floating point and they have all, but those are just add-ons, right? Those are not fundamentally different in some way. It's not like the CPU that you're learning on, like, we completely abandoned that technology. No, it has an ALU, it has an MMU, or a memory accessing, addressing bus component, right? It has, branching logic, it has flags. It's not, fundamentally, it's not that different. And the idea is that, again, the assembly language that you write for learning purposes is not, it doesn't have to port. What happens is in your head. It's the way you think about it that's important. Because what you'll begin to understand is that, there's a load instruction on an 8085. There's a way to load on a 64-bit Intel chip. There's a way to load on a 64-bit ARM chip. They're not fundamentally that different. They run a lot faster now, and we now have CPUs that have multiple, we have a CPU that has multiple cores on it, that's, again, it's just all scaling, it's just all more. It's not different. It's not like, to use some science fiction term, nowadays we use, silicon-based computers that are simple binary, and we go to duotronic, whatever the hell that means, right? And that's like some completely new paradigm that the two are not the same. No, that's not the case, right? Relort asks, what do you think of Jonathan Blow's new programming language? I think, so first off, Jay gave me motivation, I guess, to work on, base code. So I'll give it props for that. I don't know. I mean, again, I think John's going in the right direction with some stuff. I mean, he obviously has the concept of metaprogramming in there. And it's hard to tell, right? Because we're just watching very limited interactions with him and the language on streams. But it seems to me, right, if I compare videos from 2014 and 2015 to today, he seems less enthralled with metaprogramming than he used to be. He seems to shy away from it more. And again, this is just my impression. I don't know that these are facts. I also have noticed, because I've watched a fair number of the videos, the language has seemed to accumulate a lot of cruft over the past 4 years. What do I mean by that? If you look at the code, like, you will see compiler directives everywhere. He has compiler directives on procedures, on variables, on type declaration. I mean, he just has compiler directives everywhere. And that kind of, okay, first off, before I go any further, I am not criticizing this. This is just my observation of what I see, right? And it's just the way I react to what I'm seeing on screen, okay? I don't know John, I'm not in his head. I don't really know what's going on. All I know is when I watch a stream with him programming, I just know what I'm seeing, right? And my interpretation may be incorrect. But I think what may be happening is that they're building this game, this Sokoban game, whatever that's ultimately going to be called, I have no idea. And here's the problem. When you have a product like that you want to ship, that becomes the priority, right? And the compiler takes a back seat. The language takes a back seat. And what happens is, oh, we need to do this thing in this game, but we can't because of this. Okay, just add this into add in this magic little autocast thing, or add in this magic compiler directive that just does it for now, and we'll come back to it, right? But before you know it, right, you have this, you've added like 500, I'm exaggerating, but you've added a lot of things, right, to the compiler to patch around the fact that you're busy trying to get this game built. And I don't know. I mean, I'm not saying that's wrong necessarily, because at the end of it, yeah, you're going to end up with a compiler that has all this stuff, and then you're going to have to spend time like whittling it down. Okay, do we really need all these compiler directives to do all these things? The language seems kind of inconsistent, which might be why he always, admonishes that the syntax is not fixed, right? So maybe that's essentially a catch-all that means, look, I'm just putting anything in here I need to get this thing built, and then when we're done, we're going to go back line by line and literally tear the whole thing apart and figure out what it is we want to keep and what we want to throw away, right? That could be. I don't know. I think, so as far as I know, and again, I haven't watched the most recent videos, although I don't think there has been anything specifically about the compiler super recently. I don't think Jay supports like UFCS, and I think John has said he's not going to support that. I know like John's pretty much against the whole behavior on types thing. I'm somewhere in the middle on that. I think there is some advantage to having some kind of behavior on types. I don't think throwing out the baby with the bathwater there is necessarily a good thing. Because what you end up with is, if you look at, again, I'm just going based on what I see on the screen, you end up with a lot of procedural code that takes like 25 parameters because like there's no anchor points, right, anywhere. And to me, that's like drifting really super far towards one side of it, right? And to me, UFCS can be done without any performance cost, right? It's when you start getting into polymorphism and saying, oh, you have to use inheritance as a way of doing dynamic dispatch. Like, I don't want to go to that extreme. I think if you want that, you can build that, right? That's my approach to that. But at the same time, I think the language probably should support, similar to like the way Rust does, right? Where you could then have a trait system fairly simply implemented in the base language. Beyond that, I think, if you've not seen Odin, you can take a look at Odin. Odin's actually, like, the code's public and it works. And Odin is, as near as I can tell, an almost exact duplicate of J. Now, there are some differences because Ginger Bill has taken Odin. He's actually taken it down a path of trying to get it to finish it so it can be usable. And there are some variations, but I mean, if you wanted to get a feel for what the syntax of J is, how the language works. Now, Odin does not have any compile time metaprogramming. It doesn't support that yet. I think Ginger Bill's working on it, but he didn't build Odin with that from the beginning. And so now he's having to go back and I think replumb a lot of things to get to that point. But yeah, if you wanted to kind of get a feel for like what J is, you could just use Odin. It's basically the same thing. And it's out there and it works to the extent that it does. And I don't know that you could really build much with it yet. I've built like tiny little things with it. But I think the very last thing I would say about J how do I want to say this? John has been very much against self-hosting J. And I find that very curious. JAI is the name of the language. I pronounce it J. I don't even know how you really would J, yeah, it's just J. So okay, so you're trying to make a new programming language and you're really his target audience. You have to understand, like, and I think this is fair to say based on like what he said on video about it. I don't think John gives a shit if anybody uses J for anything web, anything that today people write code for. The only thing he cares about is game development, which is fine. That's great. That's his focus. But here's the challenge, right? So you write this new language, and if you're going to use it for yourself, wonderful, right? And I think that's a given. He obviously is already doing that. But if you want your fellow colleagues, especially your AAA colleagues, to use this language, how do you sell it to them, right? And by sell here, I don't mean monetarily. I mean, how do you sell them on the idea? How do you get them to even consider it? And I think the way that you get them to consider it is you say, well, the compiler is written in C++, right? That's the way you do it. And that is interesting, right? Because then what do you have? You have this preprocessor, right? That's probably the way they're going to look at it. And knowing game developers, right, they're going to take the compiler and they're going to adjust it. Well, if that happens enough, then how many versions of the language do you end up with, right? And so that seems to be more evident in my mind right now than it was maybe 2 years ago. And yeah, I'm not sure how that plays out, right, in the end. I don't know what you end up with. And I think ultimately, just to wrap that up, I think just like myself, like I'm writing base code. I have absolutely zero expectation that anybody else will ever use it, and I'm not even going to try to sell them on it. If people find base code and they like it, and they want to use it, great. If nobody ever uses it, then I'll use it and I'll be totally happy. And I think it goes without saying that in the end, that's probably, where John's head's at, right? It's a language for him and his team, I guess, by extension. But if nobody else ever uses it, oh well, right? He gets the benefits of it because it's his design. So anyway, those are my current thoughts. And who knows, like he might come out with some new videos and, my thoughts will change. So, but that's currently where my head's at with it. Magnum Baguette says, how long have you been coding? Well, a long time. Let's see. Well north of 30 years. Let's put it that way. Well north of 30 years. You are probably using an 8085 emulator. I used an 8085 in real life. And that was pretty cool at the time. I don't want to say it was cutting edge, but it was pretty good. Okay, so you're using a real one. That's good. That's positive. But nice. Yeah, so anyway, long time. My monitor was a green screen, monochrome for years. Color was a new thing. No. An emulator is just, you can run it on modern hardware, right? It's just, you don't have to deal with using something other than whatever your main system is. But I actually think using the real thing is good. I mean, I think that's a even better experience, right? And I'm assuming if you have a kit, you're probably dealing with address lines on the CPU and data lines on the CPU and all that good stuff. That's all awesome stuff, right, to understand. So yeah, I think that's actually really, really awesome. Yeah. So if you have that, that's definitely the way to go. I mean, you can do the same thing in an emulated environment, but I don't think it has quite the same impact. I don't know, maybe Stallman had gray in his beard. Nah, he He was probably pretty young. Free software was probably just a glimmer in his eye at that point. Yeah, I would, if you can, absolutely. And if you have the access to an oscilloscope, Logic Probe would work too. Yeah, you can learn a lot. Pretty awesome stuff. Well, I was going to write some code here, but I actually have to stop at about 7:45 today. So if anybody has any other questions, I got a couple more minutes here. Yeah, I mean, electronics is good. If you really want to understand, computers, it's digital electronics is, again, it doesn't have to be the thing that you focus on forever. But in terms of really understanding what's going on, it's invaluable. It really is. Not many. Ooh, a compiler in Rust. Nice. Somebody trying out Pico 8. Learning Emacs. Well, I say we give this compiler in Rust a shot here. That's pretty cool. All right, everybody. I will be back in line tomorrow at 5 a.m. and we'll be back in compiler land. And yeah, yesterday I meant to do a bunch of work after the stream, and then I got sucked into some other crap. Ended up taking my entire day, which wasn't my intention. So hopefully today I have a better shot at getting more done. And yeah, wherever I leave off, we'll pick up tomorrow morning. So thanks everybody for dropping by. I'm gonna raid this guy here. Let's see. switch. There it goes. All right. Here we go. Everybody have a good one. We'll see you tomorrow. Say hi to Musin.